essays. Huh? Essays. The things you do in composition, English 1101, 1102. So, first thing, you will have to state your hypotheses. The hypotheses are verified. Now, theorem has hypothesis. If this and this and this and this and this, then this. We are in the proving business. If you're a mammal, your blood is warm. If your blood is cold, you're not a mammal. Logic. Now, where is f of x coming from? F of x is coming from your sequence. For example, this is a sequence. And it's most certainly decreasing because it's 1 over ln. And I'm going from 1 to infinity. And at least one to the root of ln. From 1 onwards, it's increasing, so 1 over is decreasing. So in this case, my f of x will be what? It comes from your sequence. What is my sequence? 1 over ln I plus 1. That's to say when I is 1, it's 1 over ln 2. And when I is 2, it's 1 over ln 3. And when I is 4, it's 1 over ln 4. 1 over ln 5. Okay? So in this case, f of x will be 1 over ln x plus 1. You have a sequence in your hand that is coming from your series, and if you don't know what your sequence is, I told you, take your sweater out and hide it. There it is. The thing that you are trying to add. That will tell you your function. And then you will obtain your function. You will have to verify that your function is decreasing. Because if your function is decreasing, the hypotheses of the integral test are not verified, so you can't use it. You have to use something else. Now, so you have a decreasing function that is evaluated at the integers, and when you evaluate this function at the integers, it picks up your sequence. If you take this function and you evaluate it at the integers, you pick up your sequence. At the integers b, 1, 2. In this case, the height of this would be 1 over ln 2, which would be the first term in my sequence. This would be 1 over ln 3, which would be the second term in my sequence. This would be 1 over ln 4, which would be the third term in my sequence. And my point is now to add them all up and determine if this thing is finite. Now, what does the integral of this function have to do with anything? If you are only evaluating this function at the integers. But if you are evaluating this function at the integers and the space between them is 1, then these are giving you rectangles, rectangular areas. That is the height multiplied by the width. If the width is 1, then the height gives you the area of that rectangle. the area of that rectangle there is what? 1 over ln 2. And what is the area of that rectangle? Well, you take the height, and the height is 1 over ln 3. Multiplied by the width, which is 1. Well, don't worry about it. And what's the area of that rectangle? Well, you see the point. Now, what is the relationship between the area of those rectangles and the area of under your curve? That is a very important relation. In this particular case, the areas under my rectangle are more than the area under my curve. So I'm hoping to show what? That the area under my curve is finite or infinite? L-O-G-O-S. Am I trying to show that the area under my curve is finite or infinite? As per the logos, that is to say, logic. Well, let's see. Supposing the area under the curve is finite. I may conclude what about this area? Anyone? Huh?
It's the same, but it's also a primary.
I may conclude nothing. Because it is about. Let's try it again. Let's suppose that the area under this curve is infinite. I may conclude what about this area?
It's fine.
Huh?
That is fine.
Who is awake?
It's also fine.
Who said that? Clearly. Are you with the logos?
Yeah.
There's some serious logic here. If you show that the area under your curve is infinite, so the area anything above it, most certainly, is infinite. Let's try that again. I'm going to try to show that the area under this curve is what in this case? Finite. Because if the area under this curve is finite, I may conclude what about the area of these rectangles? It is finite. If I show that the area under this curve is infinite, I may conclude what about these areas? Nothing. Very, very delicate situation. Extremely delicate. And that is the idea behind the integral test. You're going to look at what sequence you are adding, make it a function, show that your function is decreasing, and then look at the series that you want. Do you have a hunch that it converges? Then you want to be shoving those rectangles underneath. If you have a hunch that it diverges, then you want to be shoving those rectangles above. So if you are shoving the rectangles above, you will show that the area under is infinite. If you are shoving the rectangles below, you are going to show that the area above is finite. Now, it will take you some time to get your hand around that.
So the idea is, it depends what the graph is. If the graph is above, it will be infinite, and if below, finite, right? Without calculating.